It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for gate till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack gate deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate gate challenge. Unacademy Combat. Register now.
So good evening everyone. So am I audible or not? Please check. So try to share the session guys. Let's reach it to the maximum. Try to share the session. So try to share the session guys. Let's reach it to the maximum. So good evening to everyone. Is my audio is clear? Suraj, good evening. Confirm my voice if audio and video is clear. So let me continue the session. Right. So try to share the session. Before that, try to share the session. So in the previous session, we have seen the different commutation techniques like load commutation as well as current commutation. So in this session, we are going to discuss about class C commutation or the complementary commutation, class D commutation or voltage commutation. So before that, let me introduce myself. So I am Satish Kumar Kesh Reddy. So I got AR 18 and AR 286. So I was ex-BHL employee. So I had a 10 plus years of teaching experience. I did my MTech from NIT Tirchi. So I was expertise in the subjects of power electronics, power systems and network theory. So if you use the code as KSK10, you will get the 10% discount on Unacademy Plus subscription. So here we have the two types of subscriptions in Unacademy. So one is Plus subscription. So other one is Iconic subscription. In Plus subscription, we have the live classes, the crash courses will be there. So weekly tests will be there. So doubt solving sessions also there. The classes will be held in both English and Hindi. So the rank improvement badge is also there in the Plus subscription. So the study planners will be there in Iconic subscription. So personal coach will be allotted in Iconic subscription. Doubt clearing, dedicated doubt clearing instructors are available. So personalized test analysis, study booster sessions will be available in the Iconic subscription. So now let us see the fee structure of the Plus subscription and Iconic subscription. Here if you have the choice of choosing the number of months, that is duration. So here 12 months, 18 months and 24 months subscription we have. If you use the code as KSK10, you will get the 10% discount, right? So if you are not able to bear the total amount, you can opt for the no cost EMI too. So similarly for Iconic subscription, we have the 12 months, 18 months and 24 months subscription. So if you here also, if you use the code as KSK10, you will get the 10% discount. So here also you can opt for the no cost EMI. So this is Unacademy new initiative, which was Unacademy Ask a Doubt. Here you can ask for unlimited doubts. You will get the solutions in a video format in both English and Hindi. So get assistance with your homework. Receive exact matches for your questions. So live mentoring product, this is for 1:1 live mentoring is available in the live mentoring. So an Iconic subscription. So this is Arohan batch GATE in DSE 2023. So this is for electrical. So the classes will be held in bilingual, that is both English and Hindi. So the starting subject will be the network theory. So this is Arohan batch for ECE. So this for bilingual, the classes will be held in both English and Hindi, right? The starting subject will be the network theory. So this Web batch for GATE 22 and 23. So GATE 23. So the classes will be held in English. So this is for electrical. The starting subject will be the network theory and so control systems. So this similarly the Web batch for ECE. So the new batches for CS and IT, mechanical and civil. So it is going to is started at 29 September. So this is a rank improvement batch which was going to be started at 6th October. 6th October, right? This is for electrical engineering. So the classes will be held in both English and Hindi. The starting subjects will be the network theory and analog electronics. Similarly for ECE, that is rank improvement batch for ECE. So the starting subjects will be the network theory and analog electronics. Right. So try to share the session, guys. Try to share the session. So before that, try to share the session, guys. So try to share the session. So let us discuss about Class C commutation and Class D commutation in this session. So what is Class C commutation? So the Class C commutation belongs to the external commutation. So because we will keep the additional capacitor to turn off the devices and to turn off the complementary switches. So let us see how the Class C commutation works. The Class C commutation is also called as complementary commutation. Class C or complementary commutation. Complementary commutation. So Class C are the complementary commutation. Let me draw the circuit of the Class C commutation. So here, so the circuit of the Class C commutation will be like this. So it has the resistance. Let me call it as R1. And here one more resistance is there, R2. Right? So we have the capacitance over here. So the two thyristors, that will be the T1 and T2. T1 and T2. So this was connected to the DC source Vs. This was connected to the DC source Vs. Right? So assume that initially capacitor is charged to the plus minus Vs. Assume that initially capacitor is charged to the plus minus Vs, right? So now, so let me assume this is the T1 and let me assume this is the T2. So at t equal to 0, so let the thyristor 1 is triggered. So let the thyristor 1 is triggered at T1. So thyristor 1 is triggered at t equal to 0. Let us see how this complementary circuit works. So let us see. So for example, when this condition, if the thyristor T1 is an on condition, so T1 is an on condition, what happens? The T2 will be in the off condition. When T2 is an on condition, what happens? T1 will be in the off condition. So if you observe that, so when T1 is an on condition, T2 will be in the off condition. When T2 is an on condition, T1 will be in the off condition. So that these two switches are the complementary switches. So by the complementary nature, it is turning off so both the SCRs, so that it is called as a complementary commutation. So let us see one by one. So let me draw the so different curves here. Let me draw the different waveforms, that is current flowing through the IT1 and current flowing through the IT2 here. Current flowing through the IT2. So and the current flowing the voltage across the capacitance. So let us understand the operation of the complementary commutation. So in each mode, how it is behaving, let us see here. So assume that initially capacitor is charged to the plus minus Vs. So let us assume that at t equal to 0, the triggering pulse is given to the T1. So what happens if the triggering pulse is given to the T1? So if before that, if T2 is an on condition, so the negative voltage, when it is an on condition, the negative voltage will apply across the T2, it will turn off the T2. So assume that before t equal to 0, T2 is an on condition, right? So T2 is an on condition before the t equal to 0, and Vs of 0 minus, the capacitor voltage Vc of 0 minus equal to, so Vs. Assume that capacitor voltage is equal to Vs, right? Assume that capacitor voltage is equal to Vs. So now, so let us understand, so at t equals 0, so the triggering pulse is given to the T1. What happens if I give the triggering pulse to the T1? The T1 will get into the on position. So now let me draw, so by on the T1, by switch on the T1. So in this circuit, if I close the T1, how it would be? In this circuit, if I close the T1, if I close the thyristor T1, so the thyristor T1, the capacitance is charged to the initial value is the plus minus Vs. The capacitor is charged to the plus minus Vs, and R1, R2 will be there. Right? So because of the reverse voltage applied across thyristor 2, the thyristor 2 will be in the off condition. So the thyristor 2 is in off condition and thyristor 1 is in on condition. So let me give the supply voltage here, that is plus minus Vs. So let me give the supply voltage Vs here. So now what happens here? So if you observe the circuit, so now let me find the IT1 first. IT1, what is the value of IT1? So IT2 equals 0. So because thyristor 2 is in off condition, so that IT2 equals 0. So if the T1 is an on condition, how can I find the IT1? So I can find the IT1. So for example, there is a possibility of the two currents here. So the one possibility is, so across IR1, right, IR1. So, and the next possibility is the current flowing through the R2. There are two possibilities, that is IR1 and IR2. So here IT is the combination of two currents. So which is the current flowing through the R1. Let me call it as a IT1 dash. So the current flowing through the R2, let me call it as a IT2 dash. If I find the current, how can I find the current here? So if you observe here, this was the short circuit. So this terminal is here, that is R1 and so this voltage source is connected in parallel, so that Vs by R1 is the voltage, IT1 dash equal to Vs by R1. How can we find the R2 into this one? So we can find let me take that circuit. So the one more circuit is the series combination of resistance and capacitance. How that circuit would be? So it would be R2, right? R2. So the capacitor polarity is minus and plus, the voltage polarity is minus and plus. If I apply the Laplace transform, so it will be the minus plus V naught by S. So that is Vs by S, right? Vs by S, and it is a Vs. It is Vs by S. If I draw this path in a separate circuit, what happens? So this is R2 here, and it is 1 by Cs, and it is a Vs by S. If I apply the Laplace transform, it would be like this. So from this I can find the I2 of S. From this I can find the current here. How can I find the current here? So let me find the current from this. So how can I find? So I2 of S equal to Vs by S equal to I2 into, right, I2 into R2 plus CS, R2 plus 1 by CS minus V naught by minus Vs by S, So if I find the I2 from this, so I2 equal to I2 of S equal to Vs by R2 into 1 plus, so 1 divided by S plus R2 into C. So that is, so we can write it as a 2 Vs by R2 into, if I apply the inverse Laplace for this, so I2 equal to, so if I apply the inverse Laplace for this, so which is equal to I2 into, so we can apply the inverse Laplace for this, so I will get the I2 as 2 Vs by R2 into e power minus t by R2 into C. So e power minus t divided by tau, right? So e power minus t into divided by tau, which is the 1 by R2C. So e power minus t divided by R2C. So we'll get the I2 as 2 Vs by R2 into e power minus t by R2C. So I can write this as a 2 Vs by R2 into e power minus t divided by tau, which is equal to R2 into C. So now we have find the current flowing through the thyristor. So we have find the current flowing through the thyristor 1. So how we have find? So the current flowing through the thyristor 1 equal to, so how we have find? So which is equal to IT1 dash plus IT1 double dash. Let me take it as IT2 dash. So that is IR1 and IR2. So the current flowing to the IR1 equal to Vs by R1. So which is the steady state value. Right? Which is the steady state value. So the second one is the current flowing to the R2 and this capacitance we need to find. So if I find that, so I will get the value as 2 Vs by RT into, so e power minus t by R2C. So this is the transient value. Now we got the IT1 value. How we can find the C value? So how we can find the C value, VC value? So from this, if I find the VC, so how I can find the VC? So VC equal to 1 by C into integral of I dt. So VC equal to the voltage across capacitance equal to 1 by C into integral of I dt. So the current direction is in this direction. So we are assuming that the current direction is, so if IC is in this direction, it is positive. But so in the circuit, the current flowing in the opposite direction. So that we need to take the minus sign here. Minus 1 by C into integration of I dt. So what is the I value we got? So 2 Vs by R2 into e power minus t by R2C. So that is 1 by C into, so if I make this, if I find the VC here, so VC equal to 1 by C into integral of I dt, that is minus sign will be there, so that here it will be the minus 1 by C into integration of 2 Vs by R2. I value we got as a 2 Vs by R2 into e power minus t by R2C. Into dt. So now if I find this, so I will get the, so 2 Vs by R2C, 2 Vs by R2 into C, e power minus t into R2C equal to, so here minus sign is there, so into e power minus t by R2C, R2 into C, so R2 into C divided by 1 by R2C, which will becomes the R2 into C. So this R2 into C and R2C will get cancelled out. So here minus and minus it will get plus. So here minus sign will be there. So minus and minus it will plus. So it is plus D plus K plus constant. So constant. So now if I apply the VC of 0 equal to Vs, VC of 0 equal to Vs, so I will get the expression as Vs into 2 into e power minus t by R2c, e power minus t by R2c plus Vs minus 1. So this is the expression for Vc. So this is the expression for Vc. So now we have find the VC value as well as IT1 value. So now we have find the VC value as well as IT1 value. So what is the VC value we got? So we got the VC value as, so let me take for this period. So for this period, so the IT1 equal to, so Vs by R2. So we got the IT1 equal to, so what is the Vs1? So Vs1 by R2, Vs1 by R1, Vs by R1 plus 2 Vs by R2 into e power minus t by R2c, e power minus t by R2c. So if I draw the IT1, how the IT1 will be? So the IT1 will be, so here at t equal to 0, if I substitute at t equal to 0, so it becomes the Vs by R1 plus 2 Vs by R2. So this point will becomes the Vs by R1 plus 2 Vs by R2. 2 Vs by R2, right? So this point will becomes the Vs by R1 plus 2 Vs by R2. So at steady state, what happens? So the current will reduces exponentially. At steady state, it reaches to the, after transient completion of the transient, so after some time constant, what happens? So at steady state, the current will be constant. It will decreases exponentially. At steady state, the current will becomes the Vs by R1. The current will becomes the Vs by R1. So how we have drawn? So we got the expression as Vs by R1 plus 2 Vs by R2 into e power minus t by R2c. So if I substitute, if I want to draw the IT1 waveform, if I want to draw the IT1 waveform, what happens? So at t equal to 0, this term will becomes to 1. So it becomes the Vs by R1 plus 2 Vs by R2. Vs by R1 plus 2 Vs by R2. The peak value will be the Vs by R1 plus 2 Vs by R2. Now it will reduces exponentially up to where it will reaches until this transient condition will becomes to 0. This transient condition will becomes to 0. So only the steady state value is there. So which is equal to Vs by R1. So which is equal to Vs by R1. So after this it is reaches to the steady state. So now if I draw the IT2, so during this condition, when T1 is in on condition, the T2 is in the off condition in this case. When T1 is in on condition, the T2 is in the off condition. So up to here, the T2 is in the off condition. So how I can draw the VC? So the VC equal to, we got the VC equal to, so what is the expression for VC? So VC equal to, we got the expression for VC equal to, so Vs into 2 into e power minus t by R2c, R2 into c, right? R2 into c minus 1. So we got the expression of VC equal to Vs into 2 into e power minus t by R2c minus 1. So if I substitute t equal to 0, here, so I will get, it will start from Vs. So what happens? So during the steady state, what happens? So it reaches to the minus Vs. So during steady state, this transient value will becomes to 0. So due to that, it will reaches to the minus Vs. The steady state value is the minus Vs. So that means at steady state, the capacitor is charged to the minus Vs. The capacitor is charged to the minus Vs. And it will continue up to here. So understand up to here. So let me give the clarification here. So now, if anyone joined newly, so understand this concept. So what is complementary commutation? So the complementary commutation is nothing but, so here the two complementary switches are there. By using the simple capacitance, so we are applying the, whichever be the thyristor is to be turned off, we are applying the large reverse voltage across that device. So for example, if I want to turn off the T2, I need to apply the reverse voltage across T2. To apply the reverse voltage, I need to turn on the T1. So understand here, for example, initially T1 is in on condition, T2 is in off condition. So at this condition, we are assuming that T2 is an on condition, T1 is an off condition. Now, if I switch on the T1, what happens if I switch on the T1? If I switch on the T1, this minus terminal is connected to the cathode of the T1, anode of the T1, and the plus terminal is connected to the anode of the cathode of the T1. So which makes the T2 in the reverse bias condition. So the large reverse voltage, when applied the large reverse voltage across the T2 will get turned off. T2 will get turned off. Now the T1 is in on condition. The T1 is in on condition. When T1 is in on condition, we have find the when T1 is in on condition, so we have find the IT1 value. So we have find the IT1 value. So in this IT1, we have the steady state component as well as transient component. Steady state component as well as transient component. Similarly, so we have find the VC value. So in VC also, we have the transient component and the steady state component. Transient component and steady state component. At T equal to 0, so at T equal to 0, what happens? 2 minus 1 into Vs, it is Vs. Yet transient is 0. During the steady state, it will become to 0, Vs into minus 1 equal to minus Vs. So with that analysis, so we have drawn the IT1 curve. We have drawn the IT1. So now at this instant, if I turn on the T2, what happens? If I turn on the T2, what happens? If I turn on the T2, what happens at this instant? So because if you observe the capacitor voltage, now it will be the minus Vs. The capacitor voltage is the minus Vs. So at this stage, the capacitor voltage is the minus Vs, that is minus and plus Vs. So now let me draw the second condition. At T equal to T1, let me give the triggering pulse for the thyristor A, the thyristor T2. So what happens during that condition? The resistance will be like this. The resistance will be there. Capacitance is there, right? So what is the capacitance polarity here? Before drawing the thyristors, what is the capacitance polarity here? So what is the capacitance polarity here? Here the two thyristors are there, right? So here the two thyristors are there. So the capacitance polarity is, if we are assuming that if the capacitor polarity is like this, we are assuming that plus Vs. But now at the end of the T1, the capacitance voltage will charge to the capacitance is charged to the minus Vs. So what happens? It is charged to the minus Vs. When it is charged to the minus Vs, so what happens? The T2 will be forward bias and T1 will be reverse bias. During that time, if I switch on the T2, what happens? If I switch on I give the triggering pulse to the T2 at T equal T1, so what happens? So the positive terminal is connected to the cathode of the T1 and the negative terminal is connected to the anode of the T1. So which causes T1 into the turn off state. So which makes the T1 into the off state. So during this condition, at this instant, the capacitor is charged to the minus Vs. So at this instant, if I trigger the T2, so what happens if I trigger the T2? So the T2 will turn on. If the T2 is turned on, so which causes, so because of the negative voltage here, so which causes T1 into the turn off state. Now the T1 is an off condition. So after this instant, what happens? T1 into the turn off state. T1 is in the turn off state. So now let us draw the IT2. How we can draw the IT2? The same analysis here we can apply. So IT2, let me take the R1 here. So let me take the R2 here. R1 and R2. So how the circuit will be? So the circuit will be, the current will be in this direction. So one current will flowing in this direction, right? Which is the IR1. And the second current is also flowing, so in this direction. So there is current has the two paths. So here also if I find the current here, so the current of IT2 will be, if I find the current here, so which is equal to Vs by R2 plus 2 Vs by R1 into e power minus t by R1c. E power t by minus t by R1c. So this is the current of the IT2. This is the current of the current flowing through the thyristor 2. So now we got the current flowing through the thyristor 2. So if I find the VC for this, so with the same analysis, if you find the VC for this, so if I find the voltage across capacitance, so I will get the expression as Vs into, so 1 minus 2 into e power minus t by r, so R1c. So Vs into 1 minus 2 into e power minus t by R1c. So during this condition, if I draw the current for the current and voltage, so if I find the current and voltage, now we have find the current and voltage. With this current and voltage, let me draw the IT2 and the VC. IT2 and VC. If I draw the IT2, how it would be? So the current will be, we got the IT2 as Vs by R2 plus 2 Vs by R1 into e power minus t by R1c. E power minus t by R1c, right? So now let us draw the current. So if I substitute, if I take this as a 0, if I take this as an initial point here, so T2 will be conducting here. So what is the current here? The maximum current will be the Vs by R2 plus 2 Vs by R1. So Vs by R2 plus 2 Vs by R1. The maximum current will be the Vs by R2 plus 2 Vs by R1. So what happens after that? So after that it has some transient condition. So it has some transient condition. So up to transient condition it will be exponentially decreasing. So after transient condition, when the transient becomes to 0, so when it reaches to the time constant, the transient will becomes to 0. When transient becomes to 0, it reaches to the steady state value, which is equal to Vs by R2. Which is equal to Vs by R2. This will be the Vs by R2. So what happens during that time? So during that time, what happens? The capacitor again will be charged to the, so from here to the, it will charge to the plus Vs here. If I apply the Vc value here, so it will charge it to the plus Vs here. Again it is charged to the plus Vs. So again if I turn on the T1, if I turn on the T1, what happens? T2 will get into the off position. So this is how we will draw the, so Vc and IT1 and IT2. Vc, IT1 and IT2. So voltage across capacitance, IT1 is the current flowing through the thyristor 1, IT2 is the current flowing through the thyristor 2. So now we have find the IT1, IT2 as well as Vc. So now let us find the different parameters here. How we can find, let us see. So how we can find, let us see. Let us find the different parameters. So let us find the different parameters here. So what are the parameters required here? What are the parameters required to find? So let me find the maximum value of the thyristor current, IT1 maximum. So what is the maximum value of the thyristor current in this case? So the maximum value of the thyristor current is, thyristor 1 current is, so which is equal to Vs by R1 plus 2 Vs by R2. So from the graph it will be the Vs by R1 plus 2 Vs by R2 plus 2 Vs by R2. So what is the IT2 maximum? The IT2 maximum is the maximum current flowing through the thyristor 2, so which is equal to Vs by R2. So IT2 maximum equal to the maximum value of the thyristor current 2 current equal to Vs by R2 plus 2 Vs by R1 plus 2 Vs by R1. Vs by R2 plus 2 Vs by R1. So now let us find the circuit turn-off time. So what is circuit turn-off time? So once the device is in the off state, how much duration we are applying the reverse voltage, which is called as circuit turn-off time. So which is called as circuit turn-off time. So if you observe here, so what is the TC1 here? So the circuit turn-off time here. So what is the circuit turn-off time? We are assuming that, so before T, the T2 is in on condition. The T2 is in on condition. When Vs is positive, so the T2 will get reverse bias. When Vs is positive, so the positive sign is the white sign. When Vs is positive, which device will get in the reverse bias condition? So the negative is connected to the anode, so that T2 will be in the reverse bias condition. So that this portion will be the circuit turn-off time for the thyristor 2. So circuit turn-off time for the thyristor 2, TC2. And if you observe here, so what is this portion? So this portion, if you observe this portion, so here the current is, so device T1 is in off condition, T1 current will becomes to 0. At this case, T1 current will becomes to 0. So even the T1 current is 0, we need to apply some reverse voltage. to make the thyristor off. So here, to make the thyristor off, So here we are applying the reverse voltage. We are applying the reverse voltage. So this portion we can call it as a TC1. TC1. Which portion we can call it as a TC1. So now, so this is the TC2 and this is the TC1. So now we can find the TC2 and TC1 values. So how we can find from the voltage across capacitance. Voltage across capacitance. So let us see how it is. So why it is TC1? That is circuit turn off time of the thyristor 1, because thyristor 1 is in off condition here. Thyristor current flowing to the thyristor equals 0. We need to apply the reverse voltage. When Vs is negative, so the polarity will be like this. So during that time, this device will be in the reverse bias condition because negative is connected here and the positive is connected here. So even though anode current equals 0, we need to apply some reverse voltage for particular period of the time, and the TC should be greater than the TQ. That is device turn off time. So now let me find the TC1. TC1. How I can find the TC1? So TC2. So here this is the TC2. TC2. So here at this place, at the TC2 value, so what is the voltage across capacitance? Voltage across capacitance equal to 0. At omega t equal TC2, voltage across capacitance equal to 0. If I use this, so voltage across capacitance equal to 0. So Vc is equal to 0 at t equal to TC2. At t equal to, so from here to here it is TC2, and this point we can consider as a TC2, that is circuit turn off time of the thyristor 2. So if I make this, so what is the voltage across capacitance? Vs into 2 into e power minus t by R2c minus 1, so which should be equal to 0. So here this t value we can replace with the TC2. So if I find that, so the TC2 equal to ln2 into R2 into C. Similarly, if I find the TC1 by making the, so VC1, that VC voltage across this one is 0. So what happens? The TC1, if I find the TC1, the circuit turn off time of the TC1, so what is the value? So which is equal to ln2, natural logarithmic of 2 into R1C. So T1C equal to T1C, and TC1 and TC2 are the circuit turn off times for the thyristor 1 and thyristor 2. Right. So up to here, if you have any doubt, you can ask, guys. So up to here, if you have any doubt, you can ask. So we have seen the class C commutation here. So we have seen the class C commutation. For the class C commutation, we have derived the IT1, that is current flowing through the thyristor 1, IT2, current flowing through the thyristor 2, and VC expression for the two different cases. So we have derived the expressions. From that expression only, we have drawn all these waveforms. So this is about class C commutation, and the most of the problems are coming from the find the circuit turn off time. What is the circuit turn off time? For example, if R1 equal to R2, the circuit turn off time equal to ln, that is natural logarithmic of 2 into R into C. So and the TQ should be chosen that TC should be, as we know that the circuit turn off time should be greater than the TQ. So the circuit turn off time should be greater than the TQ. So here the circuit turn off time is equal to safety factor into TQ. We will take that safety factor is a constant, so that TC should be always greater than the TQ. If safety factor is not given in the problem, so we need to assume that safety factor equal to 1, that is TC equal to TQ. So this is about the class C commutation. So let us see the class D commutation. So the class D commutation is also called as voltage commutation. Or voltage commutation. So voltage commutation. So class D commutation is also called as voltage commutation. Let us see how the class D commutation would be. So try to share the session, guys. So try to share the session, guys. So try to share the session. So let us observe the class D commutation. Let me draw the class D commutation circuit diagram. So from that, let me explain each and every point of the class D commutation so that you can understand clearly. So whatever be the questions they are asking, so you are able to answer. So now let me draw the circuit diagram first. So the circuit diagram of the class D commutation is like this. So we have the thyristor, right? We have the thyristor and the voltage source is there. We have the voltage source and the load is there. Now load is there, right? So this is the circuit. So for this circuit, so we need to add the additional elements such that, so we need to add the capacitance, right? So we need to add the auxiliary thyristor, so inductance and the diode, So this is the circuit of the class D commutation, where Tm is the main thyristor, TA is the auxiliary thyristor, so L is the inductance. So capacitance is charged to the initially capacitor. We are assuming that initially capacitor is charged to the Vs. We are assuming that initially capacitor is charged to the Vs, and IC is assumed as in this direction. If IC is in this direction, we will assume it as a positive. So we will assume it as a positive. So now let us draw the different currents here so that you will understand clearly. So let me draw the different currents here. So let me take different axes here. Let me take the different axes to understand clear. Right. So let me take the different axes here. So first let me take the IZ, that is gate pulse to the thyristors. Let me take the gate pulse to the thyristors. Assume that at t equal to 0, the main thyristor is triggered. At t equal to 0, the main thyristor has triggered. At t equal to 0, the gate pulse is given to the main thyristor. So gate pulse is given to the main thyristor. Let it be the IZM. At t equal to 0, the gate pulse is given to the thyristor. What happens if I give the gate pulse to the thyristor, main thyristor? If I give the gate pulse to the main thyristor, what happens? The main thyristor will get into the conduction state. So that Tm will get into the conduction state. Now if I draw the mode 1, so in that Tm should be in the conduction state. And this diode, what happens to this diode? Initially, if the capacitor is charged like this, is the diode is forward bias or reverse bias? Here the diode is forward bias or reverse bias. So the negative terminal of Vs is connected to the cathode of the diode, so that this diode is also in the forward bias condition. So that TA is not triggered, so that what happens? At this condition, at t equal to 0, we are giving the triggering pulse to the thyristor, so that Tm into Tm is an on condition, that is main thyristor is an on condition, because we have given the triggering pulse. And the TA is in off condition. So because we are not supplied the triggering pulse here, what happens to the diode? Diode is in on condition or off condition? Diode is also in the on condition. Why? Because diode is in, why the diode is in on condition? So if you observe the circuit, so the diode is in on condition because the negative terminal of the Vs is connected to the cathode of the diode. So the diode is in the on condition. If I draw the equivalent circuit of the mode 1, so for the mode 1, if I draw the circuit, how the circuit would be? So the main thyristor is in on condition. Right? So we have the source here. And the load is connected here. Right? Load is connected here. So what about the TA? So TA is in off condition. So we have the capacitance which was charged at plus minus Vs, and the TA is an off condition, the auxiliary thyristor is an off condition. Why? Because we are not given the triggering pulse, right? So, and the inductor will be like this. The diode will be in the on condition. So the current direction will be same as assumed direction, plus minus Vs. So plus minus Vs. So if you observe here, let me find the main thyristor current. So let us assume that I0 is constant. Here the assumption is the I0 is always constant, which is equal to capital I0. So what is the assumption? I0 is equal to constant. So now, so if I draw the I0 in this, so how the I0 would be? So I0 is the constant line. I0 is the constant line, so that we are assuming that I0 is constant. That is the assumption. The load current is constant throughout the time. So that is assumption. So now what happens? Let us see. So if the I0 is constant, so what is the current flowing through the main thyristor? Can anyone tell what is the current flowing through the main thyristor? So ITM, the current flowing through the main thyristor. So if you observe the current flowing through the main thyristor, so the IC is flowing like this. IC is flowing like this. If I apply the nodal analysis, if I apply the KCL here, if I apply the KCL at this point, the ITM is approaching and these two currents are leaving. These two currents are leaving. So that ITM equal to ITM, that is main thyristor current equal to, so which is equal to IC plus I0, which is equal to IC plus I0, where I0 is the constant. The main thyristor current at this case is equal to the IC plus I0. So we have drawn the I0 already. So what is the IC? How the IC can be drawn? How the IC can be drawn? If you observe this circuit, it is a simple LC circuit, source-free LC circuit. If you observe this circuit is like this. If I draw separately, the circuit is like this. Inductance and the capacitance is there. The circuit is like this. This is the minus plus, right? This is the minus plus and the current is flowing in this direction. So current is flowing in this direction. So current flowing in this direction. If the circuit is like this, we have already derived, so Vs minus V0 into, so the current will be the Vs minus V0 into root of C by L into sin omega t, because I0 equals 0. So Vs equals 0 and the minus V0 is the, so what is the current here? We have already derived, so which is the Vs minus V0, Vc0 into root of C by L into sin omega t. Sin omega t. So here the source is not there. Here the source was not given. So because it is a source-free circuit, so it was 0. Vs is 0. And Vc0 is given as minus Vs. So Vc0 is charged to the, at this case, Vc0 equal to minus Vs. So if I find this, so IC equal to Vs into root of C by L into sin omega t. So this was we have derived in the starting of the session only. So Vs into, so IC equal to now Vs into root of C by L into sin omega t. So Vs into root of C by L into sin omega t. Now ITM equal to, if I find the ITM, that is current flowing to the main thyristor. So what is the current flowing to the main thyristor? So which is the summation of the main thyristor current? So which is the summation of the, so IC value, that is Vs into root of C by L into sin omega t plus I0. So let us draw all these currents. So let us complete up to now. So if I draw the ITM, so that is IC, if I draw the IC, how the IC would be? So IC is like this. So IC is the current flowing through the device. So IC equal to Vs into root of C by L into sin omega t. So it follows the sine function. So which is having the peak value of Vs into root of C by omega L. Vs into root of C by L. If now I need to write the ITM, that is main thyristor current. How can I write the ITM? So if you observe here, so at this point, let me take this period as the T1. So up to T1, the current is like this. If I draw the ITM, which is the summation of the, so IC plus I0, we need to add these two waveforms. If I add these two waveforms, the waveform would be like this. So what is the peak value here? So the peak value equal to I0 plus Vs into root of C by L. So we have drawn the ITM also. Now let me draw the VC, that is voltage across capacitance. How the voltage across capacitance? If I draw the voltage across capacitance, how the voltage across capacitance? The voltage across capacitance will follow the sine waveform, so cosine waveform. The voltage across capacitance, if I find the voltage across capacitance, so which is equal to Vc equal to Vs into cos omega t. Vs into cos omega t. So if I draw the Vs into cos omega t, so how it would be? So it will reach us to the plus Vs to the minus Vs. Cosine waveform. It is like cosine waveform. So what happens during this condition? So it follows the Vc follows the cosine waveform, so that it reaches to the minus Vs. Minus Vs. But at omega equal to t, omega t equal to, so omega t equal t1. So at t equal t1, at t equal t1, what happens at t equal t1? So at t equal t1, the capacitor current will becomes to 0. The capacitor current will becomes to 0. And the capacitor voltage capacitor equal to minus Vc. At t equal to t1, so what happens? The capacitor voltage will becomes to minus Vc. The capacitor voltage will becomes to minus Vc. And the capacitor current equal to 0. Capacitor current equal to 0. Right? So if I draw up to t2, so what happens during this time? If I draw the equivalent circuit, what happens? If the voltage across the capacitance is minus Vs, so that means it is minus, now it is plus. Right? Before that it is the plus Vs, now it is charged to the minus Vs. If it is minus Vs, what happens? This positive terminal is connected to the cathode of the diode, so the diode will be in the off condition. At t equal t1, what happens? Diode is in off condition. Diode is in off condition. But the capacitor is charged to the minus Vs. So if I draw for the mode 2, how it would be? For the mode 2, if I take the mode 2 here, so how the circuit would be? So the Tm is still on condition because the current flowing to the main thyristor is not off, so that Itm will be in the on condition, that main thyristor is in on condition, and the capacitance is charged to the minus Vs, so that I need to interchange the polarities minus plus, right? So what happens during that time? So the auxiliary thyristor is there. So auxiliary thyristor is in off condition. This is an off condition. So the diode is also off condition. The diode is also in the off condition. Diode is also in the off condition. So what happens during this condition? What happens during this condition? What happens during this condition? So during this condition, so what is the value of Itm? So because there is no path for the current here, so because TA, auxiliary thyristor is in off condition, as well as diode is also off condition, so what happens? The load current flows through the Itm. So Itm equal to, so the same load current as the main thyristor current equal to load current. So which is equal to Itm, that is main thyristor current equal to I0. So what about the capacitance voltage? Will it change? So there is no short circuit path, so that the capacitor voltage is retained as minus Vs. The capacitance voltage retained as minus Vs. So what about the capacitor current? If I find the capacitor current is equal to 0. Because there is no path for the capacitor current is equal to 0. So the capacitor current equal to 0. So Vc equal to minus Vs, Itm equal to I0. So with that, let me draw for the mode 2. So mode 2. So let me take mode 2 here. This is the mode 2. So let me take this period will be the T2. So what happens during that time? So the capacitor current equal to 0. So we have seen that capacitor current equal to 0, right? Capacitor current equal to 0. What about the Itm? So the main thyristor current now it will becomes to the I0. The main thyristor current will becomes to the I0. So it becomes to the I0. The main thyristor current is equal to I0. So what about the capacitance voltage? The capacitance voltage is equal to minus Vs. The capacitance voltage is equal to minus Vs. So now at t equal to T2, I will give the triggering pulse for the auxiliary thyristor. At t equal to T2, let me give the triggering pulse for the auxiliary thyristor. What happens if I give the triggering pulse for the auxiliary thyristor? So if I give the triggering pulse for the auxiliary thyristor, so the capacitor is charged to the minus and plus, that is minus Vs. So which causes, so the plus terminal is connected to the cathode of the T1 and minus terminal is connected to the anode of the Tm. So what happens during that time? The Tm will be off condition. When auxiliary thyristor is in on condition, so due to application of reverse voltage, the main thyristor will get into the turn off state. So why it is getting to the turn off state? So if I apply the if I on this auxiliary thyristor, now it was forward bias because so the polarity has changed. Minus Vs is like this. The positive is connected here. So the positive is connected here so that it will be the forward bias. Now if I give the triggering pulse at omega t equal T2, at t equal T2, so what happens during that time? At t equal T2, if I give the triggering pulse, it will short, right? It will short. If it is short means this positive terminal is connected to the here and negative terminal will be connected here. So which will reverse bias the large reverse voltage is applying across the thyristor, which makes the thyristor into the turn off state. Which makes the thyristor into the turn off state. So that the thyristor current will becomes to 0. The thyristor current will becomes to 0. Now let us analyze that condition. So now what happens at omega t equal to T2, the auxiliary thyristor is an on condition. The auxiliary thyristor is an on condition. Diode is an off condition. And the main thyristor is also off condition. So let us analyze that condition. Let us analyze that condition. Let me take the mode 3. Let me take the mode 3. So in mode 3, what is happening? Let us see. In mode 3, what is happening here? So the main thyristor is an off condition. Main thyristor is an off condition. So the capacitor is charged to the minus plus Vs. Minus plus Vs. That is, it is changed to the reverse voltage. So now the auxiliary thyristor is an on condition. Auxiliary thyristor is an on condition, right? Auxiliary thyristor is an on condition. The load is connected here. The load is connected here. Source will be here. So it will be the Vs. Source will be the Vs. So now if I find the V0, so what is the V0 here? Now let me find the V0 here. Let me find the V0. So what is the V0? So minus Vs plus V0 equal to 0. If I apply the KVL, if I start from here, minus Vs plus V0 equal to 0. At this condition, V0 equal to 2 Vs. V0 equal to 2 Vs. At this condition, V0 equal to 2 Vs. Right. So now let us find the remaining parameters. So what is the main thyristor current? The main thyristor current equal to 0. The main thyristor current equal to 0. Main thyristor current equal to 0. So now, so what is the capacitor current? What is the capacitor current? So we are assuming that if the capacitor current is in this direction, it is positive. The reference direction we have taken in this direction. Now, but how the current is flowing? The current is flowing in the opposite direction. The current is flowing in the opposite direction because I0 will be in this direction when the TA is in on condition. So TA will allow the current only in this direction. So that IC equal to minus I0. IC equal to minus I0. So IC equal to minus I0 here and ITM equal to 0, that is main thyristor current equal to 0. So what are the remaining parameters we need to find? So we got the IC equal to minus I0. So let me find the VC. So what is the VC here? So VC equal to 1 by C into integral of I dt. 1 by C into integral of I dt. So how the current would be? So the current will be I0 by C into T. I0 by C into T plus constant. I0 by C into T plus constant. So that means it will increase linearly. Now the capacitor increases linearly with the slope of I0 by C. So IC equal to I0, ITM equal to 0 and the output voltage equal to Vs. At this condition, what is the output voltage? The Vs equal to V0. The Vs equal to V0. At this condition, Vs equal to V0. So at this condition, what is the output voltage? So here also Vs is applying across the V0. So Vs equal to V0. So now, so if I draw the output voltage, also, so up to here it is Vs. Up to here it is Vs. Up to here it is Vs. Now let me draw the remaining all parameters. So what is the IC we got? IC is equal to minus I0. IC equal to minus I0. IC equal to minus I0. Right? So now, so what are the remaining parameters we have? So ITM, the main thyristor got turned off so that ITM equal to 0. ITM is equal to 0. Right? So what about the VC? The VC increases linearly. The VC increases linearly in the opposite direction. So that again it will charge it to the plus minus. It will start charge it to the plus minus. So it will increase linear. It will increase linear. So once it is reaches to the Vs, what happens? Once it is reaches to the plus minus Vs, this thyristor will get into the reverse bias. So TA will also in the off condition. So TA will also be off here. So the main thyristor is also in the off condition. So IC will be in the I0. So this is how we'll take the total circuit. IC equal to I0. Again we'll get into the initial condition here. If I draw the output voltage, how the output voltage would be? So the output voltage will be like this. So the output voltage is equal to the VC minus. So at this case, let us see. So at this case, what is the output voltage? If it is VC, so V0 equal to VC minus, so V0, VC minus VS minus VC. So if I take that, what happens? So the 2VC up to 2, at this point it will be the 2VC. So at this point TA is also off condition, so that the output voltage will be like this. So this will be the T3. Let me take it as a, so this portion will be the T3. So this will be the T3. Let me take it as this will be the T3. And last one as the T4. So T4. So we have find all the things here. So 0, and this will be the T1. This will be the T2, right? So this will be the T3, and this is the T4. So now, so up to here you have any doubt you can ask. So if you don't have any doubt, so we will proceed for the mathematical calculations too. Yes. So let us find the remaining parameters. What are the parameters all required? So let us find here. So let us find here from this graph. So now the first one is, what is the peak value of the main thyristor current? Can anyone tell what is the peak value of the main thyristor current? So what is the peak value? So this is the graph. So what is the peak value? Where the peak value occurs? At this point. Now what is the peak value? So I0 plus Vs into root of C by L. I will use the white color. So I0 plus Vs into root of C by L. So which is the peak value of the main thyristor current. So now let us find. So what is the peak value of the auxiliary thyristor current? So during this period the auxiliary thyristor flows. So the auxiliary thyristor current equal to capacitor current. So which is equal to I0. So the peak value of the auxiliary thyristor, it is a main thyristor. So the peak value of the auxiliary thyristor current will be. I0. So what is the circuit turn off time? So where we need to find the circuit turn off time. So let us find the circuit turn off time. So here, so this portion will be the circuit turn off time, will represent the circuit turn off time. Why? Because observe this circuit. So this portion will become the circuit turn off time. So why? Because the main thyristor current is 0 here. The main thyristor current equal to 0 at this instant. At omega t equal T2, the main thyristor current equal to 0. So after that, we are applying the reverse voltage across the diodes, thyristor. To make the device into the successful commutation, the anode current should be equal to 0 and the reverse voltage also should be applied across the device. So here, this is the circuit turn off time TC. What is the slope of this line? So what is the slope of this line? I0 by C. If the slope of the line is I0 by C, so if the height is, so this period will be, this is the Vs, from here to here it is Vs, right? The y-axis is Vs and the horizontal axis is Tc and the slope of the line is I0 by C. So from this we can find, right? So the y-axis is y2 minus y1 is Vs. So this height is Vs, right? This portion will be the Tc. So x2 minus x1 is Tc and this slope was calculated as, and this is a straight line, this is a straight line, and this slope will be the I naught by C. So this slope will be the I naught by C. So now we can find the circuit turn-off time equal to, so here we can find the circuit turn-off time. How we can find the circuit turn-off time here? So the circuit turn-off time equal to C into Vs divided by I naught. C into Vs divided by I naught. So this is the circuit turn-off time. So now let us find the V naught value. How the V naught can be determined? So from here to here, if you observe, from here to here, we can call it as a turn-on time of the device. So the main thyristor is on for this period, 0 to T2, the main thyristor is an on condition. So that we can take it as a T on period. We can take it as a T on period, on time period, on time of the thyristor. And this T4 minus T2, this period we can call it as a, so T4 minus T2. Let me take this period as the T4 minus T2. T4 minus T2. So now how the output voltage waveform? The output voltage waveform is Vs up to here. Vs up to here. So and it is a triangle. So it is forming a triangle from here to here. From here to here. So now we need to find the average output voltage. How I can find the average output voltage? So the average output voltage is equal to, let us find the average output voltage. How we can find the average output voltage? So the average output voltage V naught equal to Vs into T on. This height is Vs and this width is the T on. Vs into T on. Vs into T on. So this will be the triangle, right? This will be the triangle. So I need to take the half into base into height. So the base is equal to the T4 minus T2. The base is the T4 minus T2. The base is the T4 minus T2. Height is the 2Vs. Height is the 2Vs. This height will be the 2Vs. So into 2Vs. Into 2Vs. Divided by T. Divided by T. So this is the V naught. How we can find the T4 minus T2 here? So this T4 minus T2 here, the slope also. So this is having the slope also I naught by C. So this will reducing with the slope of I naught by C. I naught by C. So if I take the height is 2Vs, right? Height is the 2Vs. So the width is the T4 minus 2. From this, if I take this triangle, let me represent with other color. If I take this triangle, so what is the height here? So 2Vs. So what is the width here? So x value will be the T4 minus T2. So 2Vs divided by T4 minus T2. T4 minus T2. So which is equal to I naught by C. Which is equal to I naught by C. And this slope is equal to I naught by C. I naught by C. So now if I find the, so T4 minus T2. T4 minus T2. So which is equal to 2Vs into C divided by I naught. 2Vs into C divided by I naught. Now let me replace the 2Vs into C divided by I naught with the T4 minus T2. T4 minus T2. 2 and 2 will get cancelled out. If I take Vs outside, how the Vs will be? T on plus. So what is the T4 minus T2 we got? 2Vs into C by I naught. 2Vs into C by I naught. So divided by, so total time, divided by total time. So which is called as turn on time T on dash. Let me call it as a T on dash. T on dash. So we can write the V naught as Vs by T into T on dash. T on dash. So which is the expression for V naught? So where T on dash equal to T on plus 2C into Vs by I naught. So this is how we'll find the output voltage. So this is how we'll find the output voltage. So this is how we'll find the different parameters. So most of the cases in problems they will ask about peak value of the main thyristor current and the peak value of the auxiliary thyristor current. So they will ask about the circuit turn off time and output voltage. Most of the time in voltage computation, these are the questions they will ask, right? So if you have any doubt till now, you can ask, guys. If you have any doubt till now, you can ask. Tomorrow let us solve the problems on commutation. So tomorrow let us solve the problems on computation in the evening session. So till now, if you have any doubt, you can ask. So up to now, if you have any doubt, you can ask, guys. So we have seen the class C computation and class D computation. So class F computation is the natural computation, which is simply, if you understand the half-wave rectifier, that is the class F computation. We will discuss later. So up to here we can close the session. So class C computation is called as complementary computation. The class D computation is called as voltage computation. Yeah, lengthy but easy. But lengthy it is, to understand the concept it is lengthy. But when you solve the problem, you will realize that it is very easy. So ultimately we should be able to solve the problems, numericals. Right. So with this, let me close the session. Thanks for attending the session, guys. So do subscribe and share the session. So do subscribe to channel. So still, if you have any doubt, you can raise about class C computation and class D computation. Right. Thanks for attending the session, guys. Thank you so much. Thanks for attending the session. Let us meet tomorrow.